Hi there, freshman. Welcome back to our discussion on Math 114 Differential Calculus. We will now continue our discussion for functions. In this video, we will discuss the different operations and functions, including composite functions. So, let us start. After watching this video, you are expected to be able to evaluate operations and functions, and evaluate composite functions. Recall that a quantity y is a function of another quantity x if there is a rule such that when a value is assigned to x, it will correspond to a unique value of y. The functional notation is written in the form y is f of x, where f denotes a function, y is our dependent variable, and x is our independent variable. Letters other than f may be used to denote functions such as the functional notation y is equals to f of x allows one to assume specific values of x that will give a real value of y. Let us try to find the value of a function. To find the value of a function f of x for a value of the independent variable x, say x equals to a, directly substitute all x in the function by a, then simplify to get the answer. Say, let's try example number 1. So we have the given function f of x equals to 5x minus 1. We are required to find the following: f of 0, f of negative 4, and f of 2 minus x. So as we know it, we directly substitute the value of x depending on the given situation. Say, for f of 0, we substitute x to the value of 0. So we have 5 times 0 minus 1. That is negative 1. So for f of negative 4, again we substitute the value of x by the value negative 4. So we have 5 times negative 4 minus 1, that is equal to negative 21. And lastly, for f of 2 minus x, we substitute the value of x in the equation by the value 2 minus x. That is 5 times 2 minus x minus 1. Distributing the value of 5, we have 10 minus 5x minus 1. Simplifying, we have 9 minus 5x. Or we could say negative 5x plus 9. Next example. So we have the given function s of t is equal to 2t cubed minus t squared plus 5. We are required to find the following: s of 1, s of negative 2, and s of x. For s of 1, we directly substitute 1 to the variable t of the equation. So for s of 1, simplifying, we have, therefore s of 1 is equals to 6. Then for s of negative 2, we have, simplifying, therefore s of negative 2 is equals to negative 15. Then for s of x, again we simply substitute the value of x to the value of variable t in the equation. That is our s of x. And then for example number 3, we have the given function f of x equal to 3x squared plus 2x minus 1 over x plus 1. So we are required to find the following: f of 0 and f of negative 1. For f of 0, we directly substitute the value of 0 to the variable x of the function. For f of 0, we have the simplifying. So this is because we cancel this one because that is 0. Then we have negative 1 over 1, which is equal to negative 1. Then for f of negative 1, we have simplifying, we have 0 over 0, which is infinite. Therefore, the value of f of negative 1 is indeterminate. Moving on to the operations and functions, let f and g be two functions of x. The sum of functions is written in the form. For the sum of the functions f plus g, that would be written as f plus g of x. That is equal to f of x plus g of x. For the difference of two functions, that could be written as. So that is same with the sum of the functions. Then for the product of two functions, again, we just use the same property as of addition and subtraction. And for the quotient of two functions, same for all the above operations. For the product of a constant and a function, where a of course is a constant, let's now try to find the value of a function with a given operation. Example 4. Let f of x equal to f minus 2x and g of x equal to 3x minus 1. Find the following. So here are the solutions. For a, so here are the solutions. For a, that is f plus g equal to 4 minus 2x plus 3x minus 1. Or, in simplifying, we have x plus 3. And for f plus 2g, we have 4 minus 2x plus 2 times the value of the function g of x, that is 3x minus 1. So simplifying, we have, therefore f plus 2g is equal to 4x plus 2. For f minus g, we have 4 minus 2x minus 3x minus 1. Simplifying, therefore f minus g is equal to negative 5x plus 1. Then for f divided by g, we just directly substitute the valuing of f of x and g of x, which is 4 minus 2x over 3x minus 1. For gf minus f, we have simplifying, therefore g minus f equals to 5x minus 5. Note that g minus f is not equal to f minus g. Next, we have 4f, where 4 is of course constant. So we have 4 times the value of f of x, which is 4 minus 2x. Therefore, 4f is equals to 16 minus 8x. Let us proceed to g times f, that is the quantity of 3x minus 1 times the quantity of 4 minus 2x. Multiplying terms, we have to simplify and get g times f equals negative 6x squared plus 14x minus 4. Next, we have 3g minus 2f, or equal to 3 times the quantity of 3x minus 1 minus 2 times the quantity of f of x, which is 4 minus 2x. So we simplify and get for 3g minus 2f, that is equal to 13x minus 11. Then we proceed to 2 times the value of g over f. Substituting, we have 2 times the value of g of x, which is 3x minus 1, and the value of f of x, which is 4 minus 2x. Note that we factor the value of 2 in the denominator, 4 minus 2x. Then, cancel the value of 2. We have 2 times g over f equal to 3x minus 1 over 2 minus x. And finally, for g of negative 2 plus g of negative 3, we simply substitute the value of negative 2 for g of x and the value of negative 3 for f of x. So we have 3 times negative 2 minus 1 plus 4 minus 2 times negative 3. Simplifying, we have, therefore, g of negative 2 plus f of negative 3 is equal to 3. And that ends our discussion on operations and functions. Let's now proceed our discussion for composite functions. Are you ready? What are composite functions? These are functions that are combined with other functions evaluated in succession. The composition of f with g, denoted by f circle g, is defined by the symbol where the domain of f circle g is equal to the domain of g. That is to say, if we use the variable x in f of g, then we use the variable x for f circle g. For evaluating composite functions, there are steps that should be considered. First, evaluate the function g of x. Second, substitute the expression obtained in step 1 to the independent variable of x. Third, simplify the resulting expression. So let's try an example. Given the functions f of x equal to 4 minus 2x and g of x equal to 3x minus 1, we have to evaluate a, f circle g, b, g circle f, and c, g circle f of 1. So for a, we have f circle g or f of g of x. So what did we do? We just simply substitute 3x minus 1 to variable f in f of x. So when we have 4 minus 2x, therefore the value of x should be 3x minus 1. Okay, by simplifying, we have 4 minus 6x plus 2. Then for f circle g, we have 6 minus 6x. Then we proceed to b, that is g circle f, or g of f of x. So we have 3, then the value of x should be 4 minus 2x, and copy minus 1. Simplifying, we have 12 minus 6x minus 1. Then therefore, g circle f is equal to 11 minus 6x. So for c, we have g circle f of 1, or g of f of 1. So we first evaluate f of 1. So that is, f of 1 is equals to 4 minus 2 times 1 is equals to 2. Then we proceed to g circle f of 1, which is equal to g of 2. So we have f of 1 is equal to 2, then we have g of 2. We substitute the value of 2 to 3x minus 1. We have g circle f of 1 is equals to 5. Moving on to the next example, we have, given f of x is equal to 3x minus 1, and g of f of x is equals to 48 minus 2x squared, find g of negative 28. So we find the value of x when f of x equals to negative 28. Why? We have g of f of x. But also we are to find g of negative 28. So we equate f of x to negative 28. However, we have f of x equals to 3x minus 1, and our f of x equals to negative 28. Therefore, we equate negative 28 to 3x minus 1. Then simplifying, we have the value of x equal to negative 9. Solving now for g of negative 28. Using this function, we substitute the value of x to negative 28. So we have 48 minus 2 times negative 9 squared. Simplifying, g of negative 28 is equal to negative 114. For the next and final example, we have the given f of x equals to 3x minus 12 and g of x equals to x minus 1 quantity squared. For what values of x will the expression f circle g of x be equal to 0? We find the value of f circle g of x. That is, f circle g of x equals to f g of x. Then f of quantity x minus 1 squared. So we substitute the value of quantity x minus 1 squared to the f of x. That is 3 times the quantity of x minus 1 squared minus 12. Expanding quantity of x minus 1 squared, that is 3x squared minus 2x plus 1. We then have we equate 3x squared minus 6x minus 9 to 0. Note that we can factor out the value of 3 in this expression. Factoring out 3, we have x squared minus 2x minus 3. Okay? So that equates to x squared minus 2x minus 3. Note that the factor 3 was gone when we cross multiply it to 0. Factoring x squared minus 2x minus 3 is equal to x minus 3 and x plus 1. So by the zero product property, we have x equals to 3 and x equals to negative 1. These are the final answers. And that ends our discussion for composite functions. This video was made possible by the work of the following people: Dr. Maria Lea Ayabad, Engineer Rina Marie V. Pedrosa, Engineer Mark Kevin T. Sidro, Engineer Lalaine Jean Balyaes, Engineer Romeo Gibao Jr. For queries, comments, and suggestions, feel free to email me at rj.lacambra@evsu.edu.ph. God bless everyone!